This is CS1101, lecture 9.3. We're continuing our discussion of arrays, but we're also going to be discussing arrays passed as parameters to methods. So to start off, let's make a quick connection with strings. So we've been using strings for a while in this course at this point, and now that we've introduced arrays, it may have become clear that strings are actually implemented as arrays of characters. And that is accurate. That's why when we index a string, when we say we want char at 4, in this string of hey ma, we get the m, even though that's the 5th character in the string. So they're 0 indexed because under the hood they are arrays of characters. And that's why we use similar processing methods. So we use for loops to process arrays. We use for loops to examine each character of a string. Really, you were already doing array processing. We just didn't tell you that it was an array. So now let's look at how to pass an array to a method. First of all, to tell a method that you intend to pass it an array, the syntax goes like this. The method header is similar to what we have done to this point with a key change shown in blue. Public static, then the type of the return, if any. If there is nothing returned, obviously, then void. Then the method name. Then the parameter. Ordinarily, you would have to tell it the type and the name of the parameter that you would like to use inside of your method, but when you're passing an array, you give it the type followed by open and close bracket. Now, that should be similar or ring a bell to you to how you have to declare the array itself. So when we're declaring an array variable, we do the very same thing. So if the type was int, it would be int open close bracket. Remember, what we're doing here is declaring an array parameter so that when we pass some array to this method, we copy the reference to that array into this parameter. So public static, the type, the return type of the method name, then the type of the values which are stored in the array, followed by open and close parentheses or open and close brackets to tell it that this is an array, followed by the name of the array. So an example of this would be public static, and then this is going to return a double, and this is going to calculate the average, so we call it average, and then to tell it that we're going to pass it an array of integers, we say int open and close bracket, and we want to call this parameter numbers. So the way that you would then call this method would be method name, and then to pass in an array, you would just put the array name in the parentheses as the parameter. Notice there's no brackets in the calling statement, only in the method header. So then an example of this would be int open and close brackets to declare an integer array called scores, and then we are going to initialize it with these values, 13, 17, 12, 15, and 11. So this creates a new array object and populates it with those values, and then we are going to pass the scores array to the method called average. So average and then open parentheses scores. And we will capture the return value from average into this variable called avg of type double. So let's walk through this code and see what it outputs to the console. So we have a main method and we have a method called average. And we're going to call the average method and then print what is returned. So now let's examine the code. First of all, in our main method, notice every time we have declared a main method in this class, we always give it one parameter called args. And args is a string array. So it's a string type array. The purpose of this parameter is to allow for command line arguments, which you won't have to worry about or deal with at this point. So inside this main method, we're declaring an integer type array called IQ, and we are initializing it with these values: 126, 84, 149, 167, 95. So this creates the array in memory, the array object in memory, and initializes it with these values. So it's a array with length 5 and these values. Then we are calling this method average and giving it as parameter our IQ array. Now let's look at the header for this average method. We've got public static and then double, so it's going to return a double value, and then the name of the method is average, and then we've told the method we're going to pass it an integer type array, and we want this integer type array parameter to be called ARR, or that's sort of a contraction for array. So inside the average method, we are going to initialize a variable called sum to calculate the total of all the elements in the array. And we are using our typical array structure for looking at each element. We initialize our count variable I to 0. We are testing for I less than the length field in the array, so I less than array.length, and we're incrementing by 1. And what we're doing is we are incrementing sum by element I each iteration through this loop. So we will, regardless of how many elements are in this loop, we will take each element and increment sum by the value stored in that element. When there are no more elements to process, so that is to say when I is equal to array.length, we will stop processing, because when I is equal to array.length, it is no longer less than array.length, and we'll jump to the statements immediately following the for loop. In this case, that's a return statement, and it is an expression that will yield a double. So let's look at this expression. We have a cast and a division. Cast takes precedence over division, so we will change this sum to a double and then divide it by the integer array.length. And this gives us the average. We return that double. And that gets stored into AVG, and we print average equals average, which in this case, that would be 124.2. Here's the exact same code, and it would perform precisely the same as we've described in the previous slide. However, in this option, we use the for each loop. So here, inside the average method, we declare our sum variable and initialize it to 0, and then we say for each integer in array, increment sum by n, and then return sum cast as a double divided by the integer length of the array, which gives us 124.2. So here's the code we just looked at to calculate the average of the array. Instead, modify this code to find the max element and return the value. So pause the video, modify this code appropriately to find the max element and return that value. So here is one way to find the max of this array without using the sort method. So we haven't changed our array initialization, but we've changed the name of our average method to be max, and it now returns an integer value because the values stored in our array are integers. So let's look at the interior of this max method. First of all, it still expects a parameter that is an integer type array, and it's called ARR, or array, short for array. And then we declare a max so far, so our current best, our current max. And we don't know the range of possible values, so it would be silly to start at something like -1 million because we don't know that -1 million would be lower than or higher than any particular values in this array. So in the absence of any knowledge about the range of values in the array, the best thing to do is to initialize max so far to whatever the value is in element 0. Then, for each element in the array, so and then we initialize our count I to 0 because our array started at 0. We'll test I less than array.length because once the count variable I equals array.length, that means that we would be attempting to read one element beyond the end of the array, right? Because if we have a length of 7, that means our max index is 6. So we want to continue this loop until I is no longer less than our length. So test I less than array.length and increment by 1 each update. And then the test inside the if statement is fairly straightforward. If element I of array is greater than our current max so far is assigned the value stored in element I of our array. We do this for, as I said, each element in the array. So when we are done, max so far will contain the maximum value in the array. Then we return that value. So when we pass IQ, this method will return 167 and be stored in M, and we print max equals 167. Alternatively, we could have used a for each loop. So we could have said, for each integer n in array, if n is greater than max so far equals n. So understand that what we do with a typical for loop, when we are only reading values from an array, we can do with a for each loop. If we need to write values to the array, then it becomes less feasible to use a for each loop. Because though n takes on the value of each element in the array, if we change n, it will not change the element in the array. A common necessity when dealing with arrays is to swap two values. This usually comes into play anytime you're implementing a sort method. So before we look at arrays and swapping, just conceptually think about what we have to do to swap two array values. Does this code successfully swap A and B so that the value that was in A gets stored in B and the value that was in B gets stored in A? So we want A to have the value 64 and B to have the value 42. Does this code make that happen? A equals B, B equals A, print out A space B. No, it's going to print out 64, 64. Execute the code in your head. We initialize A to 42, initialize B to 64. Then we are assigning A the value 64. A is now 64. Then we assign B the value stored in A. What's in A? Well, we just assigned it 64, so the value in A is 64. So both A and B are 64. What we actually would need to do is to declare a temporary variable, set it equal to A, assign A the value stored in B, so A would take on the value 64, temp has already taken on the value 42, so temp equals 42, A equals 64, B equals 42. So now A contains 64, and B contains 42. This is the typical way that you would go about swapping two values. You have to introduce a third variable called, in this case, temp, to temporarily store one of the values so that when you move, in this case, B into A, you don't wipe out the value which was stored in A. How about this? Does this code correctly swap A and B? We have a main method. We initialize A to 42, B to 64, just as we did in the previous slide. And then we're calling this method swap. And we pass it the parameters A and B. And inside swap, we have public static void, and then the method name is swap. Notice we're not returning anything. And we have two parameters declared, int A, int B. Okay, so yeah, this will work. Swap, pass it A and B. So now we have A and B inside this method. Okay, we've introduced our temporary variable. Temp equals A, so temp takes on the value 42. A takes on the value 64. B takes on the value 42. Okay, so this A has the value 64, and this B has the value 42. Okay. However, when we print out the value of A still has 42. It didn't get swapped to 64. And B still has 64. It didn't get swapped to 42. Why not? Remember, Java parameters are initialized by copying the value from the variable into the parameter. The parameter is a copy. It's not the actual variable. So in the previous slide, when we passed A and B to the swap method, we copied the value from A into the parameter A in the method. So when we changed the variable A, or the parameter A inside the method, it had no effect on the variable A inside our main. Those are the rules for primitives. When we're dealing with an object, the value is not stored directly in the variable. When we're dealing with an object, the reference to the object is stored in the variable. So when we pass an array to a method in Java, or any other object to a method in Java, we're actually copying the address out of the variable and into the parameter. So both of them have the same address. So if I have your address and I go paint your house, when you come home to that address, your house is still painted because they're going and looking at the same house or affecting the same house. So very much the same, when we pass an object's reference into a method, and that method goes to that location in memory and uses that object or changes that object, when we come back out to the caller and we attempt to go look at that address, any effects or changes that the called method did to the object remain changed. So any changes remain because we are going and looking at the same object. That's different for a primitive, right? A primitive, the actual value is stored in the variable, so we're not dealing with addresses and objects in memory. Nope, it's a value stored in the variable, and when we copy that in, anything we do to this copy does not affect the original. But when we're dealing with objects, we're copying an address, and when we go to that address and do something to it, any other entities in the program that also have that address are also going to see those effects. So that is the explanation for why the swap method in the previous slide did not successfully swap the values in the A and B variables in the main method. Luckily, arrays are objects. They're not primitives. So we can build a swap method similar to the one in the previous slide that will work for arrays. So let's look at this code that implements a swap method to swap two elements in an array. So rather than having variables A and B, we now just have the array A. So we declare the integer array with the name A and initialize it to a new integer array object with length 2. We give the first element, or element 0, the value 42, and we give element 1, the second element, value 64. Then we call the method swap and we pass A as a parameter. So let's look at the method header for swap. Public static void swap, so that's all what we would expect. And then remember, to declare an array parameter, we say the type followed by open and close bracket. So to tell this method we're going to pass you an integer array, we say int open and close bracket, and then the name of the parameter. So in this case it's ARR, short for array. So inside we're going to declare a temp variable, because remember, if we're going to swap two things, we're going to have an extra variable to contain the first value, otherwise it'll get wiped out when we assign it the value of the element 1. So we declare our temp variable, assign it the value stored in element 0, and then we are going to assign element 0 the value stored in element 1, and then we will assign element 1 the value stored in temp, which is the value which was originally stored in element 0. So in this way, we have swapped 0 and 1. We've swapped the value that was stored in element 0 into element 1, and we've swapped the value from element 1 into element 0. Notice there's no return type, it's void, so we're not returning anything. And we come back out and we print element 0 of A and element 1 of A, and it prints 6442. So this does swap the values in element 0 and element 1, not just inside the method, but also in the caller. So in this case, the main was what called swap, so the main is the caller, and when we come back to the caller and we look at array A, the values are swapped in the caller just like they were in the method that we called. And the reason is what we discussed on the previous slide. A contains a reference to this object. This is an address. So when we have these values stored in this object in memory, A contains the address of that object. So when we pass A as a parameter into this method, we are copying the address from A into ARR. So it's two variables, but both contain the address of the same object. So inside this method, when we change this ARR object, we have actually gone to the address stored in ARR and changed that object in memory. When our program pointer jumps back out to the caller, so when we go back out to the caller, and we again look at the object that A points to, we see the changes that were made inside this method because both are looking at the same object in memory. So now let's look at how not to swap two values in an array. This looks very similar. We have our integer array called A, populated with 42 and 64. We're calling the method swap, and then we're printing the results. Same thing, so our main method's the same. We won't discuss that very much. Inside our swap method, instead of declaring a temporary variable called temp to store the first value so that we can not wipe it out, we're going to declare a new integer array called x, and we're going to set x equal to a new integer array object with length 2. So we create a new object in memory and store its address in x. So we have one array object in memory pointed to by ARR, which is the same array object that was pointed to by A, because we copied the value of A into ARR. And we now have another array object in memory, and the address is stored in x. Now, we're going to assign element 0 of x the value in element 1 of ARR. Okay, then we assign element 1 in x the value stored in element 0 of ARR. So this effectively swaps the value from element 1 into element 0 in x and element 0 in ARR into element 1 of x. Then we will assign ARR x. But this doesn't work. Let's look at why. It's all in this last line. It's all in this last statement. Remember, we copied the address of the array called A into this array called ARR. So the address stored in ARR and the address stored in A were the same address. They were looking at the same object. And then we created a new array object called X. We manipulated the values of X. Then in this last statement, we assigned ARR the address stored in X. So even though the object which we created in this method called X has the value swapped, we actually didn't change anything about the object pointed to by ARR. Because down here, all we did was move the address of X into ARR. So originally, ARR was pointing at the same object as A, but then it suddenly points at this X object. Previously in the course, we made this analogy where we send Cornelius a copy of my Word file, but I keep the original. So if Cornelius changes his version that I sent him, it actually doesn't affect my version because I sent him a copy. This is how it works with primitives. Right? The value is stored directly in the variable. So when I call a method, I copy that value into the parameter for the method. And so any changes done to the parameter inside that method occur on the copy, but it has no effect on my original. However, if I instead create a Google Doc and I send Cornelius the address of that Google Doc, and he makes modifications to the Google Doc, then when I go look at it, I will see his changes. Because fundamentally, there is a single document, and we both have the address of it. So what I copied and sent to him was an address for where to go look at the document in Google's memory. This is how it works with objects. Primitives store the actual value in the variable. Objects store the address or the reference of the object. So when you create an object variable, it doesn't contain that object. It contains the address of that object. So when we pass an object to a method as a parameter, it copies Just like it does with a primitive, it copies the value stored in the primitive into the method parameter. Well, when we deal with objects, it copies the value stored in the variable into the parameter. It just so happens that the value stored in the variable for an object is the address of where to go look at that object. So when we pass an object variable into a method, it copies the address into the parameter. So now both the original variable and the parameter both are looking at the same object because they both have the same address. Just like if I sent this email to Cornelius, there's one Google Doc, there's one object in memory, and I'm the caller, and so I can go look at this object in memory, or Cornelius, who I sent this email to, can use the address that I copied and sent to him to go look at this object in memory. This is how objects work. So let's go back and illustrate and make sure we fully understand why the first version of our swap worked. So we have our main, which has been the same in all the examples. We have declared an integer array called A, and we created a new integer array object of length 2 and stored the address of that object in A. Then we gave the element 0 in A the value 42 and element 1 in A the value 64. So understand at this point we have A pointing at this object in memory, which has 42 and 64. Then we call the method swap, and we pass as parameter to this method A. When we pass it as a parameter, we copy the value stored in A, and the value stored in A is the address of this object. So we copy the address of this object into this parameter called ARR. Then inside this method, we created a temp variable to hold the value stored in element 0. Then we assigned element 0 the value stored in element 1. So at this point we have down here temp equals 42. And when we assigned the value stored in element 1 to element 0, this took on the value 64. Then when we execute the next statement, we assign the element 1 the value stored in temp. So this becomes 42. And that's the last statement in our method. So our program pointer jumps back up to the next statement following our call. And we print out element 0 of A, followed by space, followed by element 1. Now, yes, we changed it in this method, but we changed it by using the address stored in ARR, which just happened to be the same address stored in A. So we went to this location in memory even though we were inside a method. So when we come back out to the main, we follow this address to that same location in memory, and we print out element 0, which is now 64, and then print out element 1, which is now 42. Any changes made in the method to which the array was passed as parameter will be still in effect when you go back out to the caller. So of course there's not arrows in the computer. That's not how addresses work. Addresses are more similar to like a URL. It's a location in memory inside the computer. And the object name, the variable, holds that address. We don't have to care about what the address is that's stored in the variable. We let Java deal with where to put objects in memory and things like that. We don't have to worry about that. What we do care about is whether or not two variables, or a variable and a parameter, contain the same address. Because if they contain the same address, then they're looking at the same object, like having keys to the same house. We mentioned this before, but that's the reason that printing an array object doesn't work. We can't say system.out.println and then just the name of the array. Because what's stored in this array is actually the address. So this will just print out array address is : and then wherever the array is actually stored in memory inside the computer. So now let's take another look at our second attempt at the swap method that didn't work. In our swap method, we originally pass in a reference to the object we want to swap, the array object that we want to swap the values of. So we have address number 1 here, and then we create another array object called x, and it contains a different array object address. So we'll call that address 2. So ARR has address number 1, but x has address number 2. And we initialize the contents of the array to be element 1 from ARR and element 0 from ARR. But then we change ARR so that it no longer refers to address 1 and instead refers to address 2. So this changes our parameter but has no effect on the caller, because we're not actually changing the object in memory. Here we're just changing the address stored in ARR. So let's look at an illustration of how this code executes this wrong code that does not correctly swap the values so that the original object is changed. The red shows the statements which have already been executed. So up to this point we have created the integer array object called A and given it a location in memory. So we are pointing at this object. We initialized it with the values 42 and 64. So 42, 64. And then we have called the method swap and passed A as the parameter. When we pass a parameter, we copy the value stored in the variable into the parameter. So the address stored in A is copied into ARR. And that's how far we've executed at this point. So see that we have A pointing at this object in memory, and we have ARR also pointing at this object in memory. Notice there's two separate variables. There's a variable A, which contains the address to this object, and there's the variable ARR, which also contains the address of this object. So we execute a little further. We create another integer array object called x with length 2, and we initialize it with values from our previous object. So we have created this object in memory, and we have a variable x that contains a reference to this object. But notice we have not executed this last line of the code. So let's look at what happens when we execute that. When we execute this last statement, what we're doing is we're taking the address stored in X and putting a copy of that address in ARR. So previously, A and ARR, two separate variables, both contain the address of this object in memory. However, when we execute this statement, we take the address stored in X, which points to this new object, and we store that address in the variable ARR. So now ARR points at the same object as X. This is the reason that when we go back out to the caller and print element 0 space element 1, it's unchanged. We actually didn't do anything to this object. We copied the address into a parameter, and we copied elements from this object into a new object, but we actually didn't do anything other than just read the values which were already stored in this array. So here's a mini exercise to test your knowledge and your understanding. See if you can tell what is going to be printed by the print line statement. So we create an integer array variable called A1. That's a variable that is going to hold an integer array reference, or an address. And we are creating in memory an integer array object initialized with these values, and then we assign the address of that object to A1. In the next line, the next statement, we create another integer array variable, so another holder for an integer array address. But rather than creating another object, we're taking the address stored in A1 and assigning that address into A2. So at this point, A1 and A2 both look at the same object in memory. So A1 looks at this array, and A2 is looking at that same array. Then we execute this line in blue. We assign the value 7 to element 0. So now, when we print out A1 element 0, what should be printed? It prints 7. The reason is because both of these variables contain the same address. They're both looking at the same object. So even though we changed A2, what we actually did was we went to the address at A2, which happens to be this object. So we went to the address at A2, and we changed element 1 to 7. So then in this line, when we go to the address stored in A1 and read element 0, it's still a 7. So what will the following code print? This is another mini exercise. Take a moment, pause the video, and decide which of these options will be printed by this code. So we're creating an integer array called X, which is going to have length 10. And then we're taking the address of that array and storing it in another integer array variable called Y. So X and Y both point at the same object. And then we're creating a new integer array object with length 10 and storing its address in the variable Z. In this statement, we assign element 0 of X the value 100. Remember, X and Y are the same object. We assign element 0 of Y the value 50. That overwrites our 100, so now this object has the value 50 in element 0. We assign element 0 in Z the value 20. Remember, Z has its own object. It's not pointing at the same object as X and Y. So it has element 0 value 20. So when we print out element 0 of x, element 0 of y, and element 0 of z, we will see 50, 50, 20. So when you're dealing with the arrays class, you might find it odd that we don't have to typically get a return value from the method and do anything with it. The reason that we don't have to get the return value is exactly what we've been talking about. When we pass in this nums array, so we've created this array object in memory, and we store the address in nums. It's an integer array object, and its address is in nums. And we print out arrays.toString of nums. It prints out the array 4, -1, 2, 7, 3, 6. And that's exactly what we initialized it with, so that makes sense. Then we call the sort method, arrays.sort, and we pass as parameter nums. Notice we're not getting any return value from arrays.sort, but when we print arrays.toString of nums again, notice how it has changed. Now it is in ascending order, -1, 2, 3, 4, 6, and 7. The reason is we pass the address to this array object into the sort method, and it changed that object. So then when we look at that address again, it is still changed. Then when we call arrays.fill and then give it the array and the value we wish it to fill it with, and then print out the array again, we will see that it is now filled with the value 42. So it may seem a bit odd that you pass arrays into a method and it changes the array inside the method, and those changes are reflected in the original variable. But that's because we're passing in an address which these methods use to make the changes to the array objects in memory that we requested. So just as a reminder, string objects are immutable. This is sort of an asterisk by strings. So everything we've said about objects being passed in and changed inside of a method being reflected in the caller is 100% true. However, you cannot make use of this when dealing with strings because you're not allowed to change a string object once it has been created in Java. If this bothers you, check out the String Builder class, which uses a variant of strings that can be changed. However, we don't use String Builder in CS1101.